This is Molkishan, lecturer in chemistry, Government Degree College, Siddipet. Today video is chemical properties of carbonyl compounds, PART-3. In this one, the addition with ammonia. Here ammonia NH3 acts as a nucleophile only. Nucleophile due to the presence of lone pair of electron at nitrogen in ammonia. That's why the carbonyl compound reacts with NH3 to form only this one, OH NH2. This is the addition product. Addition product. Mechanism: direct the carbonyl group approaches NH3. The lone pair of electron is donated to carbon. Here the pi bond shifted to this side. At that time, O minus a new bond with nitrogen, and already 3 hydrogens are present. It is donated plus it is the pi bond shifted towards the oxygen. Oxygen get negative charge. At this position only, this one shifted to this side, and H plus ion shifted towards the oxygen. Here bond shifting, negative charge plus positive charge neutralizes. Here H plus OH minus, here also neutralizes. So this is the product. This is the product. But here, this is the general mechanism. Carbonyl compound reacts with ammonia to form addition product. This is general. But different compounds, you take formaldehyde, you take aldehyde, you take benzaldehyde, you take ketone or acetone, different products will be obtained. Okay, that is due to the high reactivity of this addition product. In this one, the first one is with formaldehyde. Addition formaldehyde and ammonia reaction. Formaldehyde and ammonia reaction. Formaldehyde, HCHO is called as formaldehyde. This HCH and NH3 only reacts to form this one, NCH2 taken 6 N4. This is called as hexamethylate tetramine. Hexamethylate tetramine. Another name of this one, urotropine. Urotropine. Here balancing totally 6 molecules of formaldehyde required and 4 molecules of NH3 is required. Okay, and forms this one. Here the reaction we can show like this one only, CH2 double bond O. Before going to write this structure only, structure of urotrope only. Structure of urotrope is N CH2 and CH2, here N and CH2, here N CH2, this one, and here CH2, 1, 2, 3, and CH2, 1, 2, 3 bonds, 3 bonds. Here N, CH2 and CH2, here CH2, 1, 2, 3, 4, 5, 6. Okay, this is the structure of eurotrope anti. 1 N, second N, third and fourth. Here CH2, 3 CH2 and 3 CH2. So this is the shape of or structure of eurotrope anti. Based on that one anti. Here O, N, H2, H anti, and one more here plus N, H, here H, H, and CH2 double bond O, here N, H, 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 and here CH2 double bond O, here N, H, N, H, 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 here CH2 double bond O, here also CH2 double bond O, here also CH2 double bond O. Based on this one only, all are this formaldehyde and ammonia units. This is the formaldehyde and ammonia. And ammonia molecules 1, 2, 3, 4 ammonia molecules. Formaldehyde 1, 2, 3, 4, 5, 6. And now here first one, this will be bonded and only single bond. Due to that reason, here only H and this one. This is one water molecule is eliminated. Nitrogen to carbon. HOH eliminated. Here also only. This is one H, and here also one water molecule is eliminated. Here also one water molecule is eliminated. Here also one water molecule is eliminated. From here to here. Here eliminated. Here also one water molecule is eliminated. From here to here, bond only. Here also one water molecule is eliminated. From here to this one only. Eliminated. That's why how many water molecules only? 6 water molecules are eliminated. Okay. Anyway, this is the some convenience only. If it is problematical, you see only this 6O only. From here 4 3 is 12, and the total 12, 6 2 is 12, 4 3 is 12, 12 hydrogens from ammonia, 6 oxygens from formaldehyde eliminated as a water molecule. That's why formaldehyde reacts with ammonia to form hexamethylene tetramine. It is also called as eurotrope. Structure of eurotrope is this one. And the eurotrope is used as a antiseptic for the urinary problems. Urinary problems. One more application of this one. Eurotrope is used in the preparation of RDX. This is CH2 only. This is one. Here nitrogen. Here CH2. Here nitrogen. CH2. Here CH2 nitrogen. When it is reacted with concentrate HNO3 only, it forms only this one only. Nitrogen, CH2, CH2, nitrogen, nitrogen, CH2, and this is CH2, here CH2, here CH2, here nitrogen is substituted, NO2 group is substituted. This is called as RDX. RDX, research development explosive only. Explosive, highly explosive, which is eurotrope is converted into RDX by mixing of HNO3 and okay. Again, carefully listen. Formaldehyde reacts with ammonia to form hexamethylene tetramine. It is called as eurotrope. Structure of eurotrope is this one. Okay, and eurotrope is used as a antiseptic for the urinary problems only. And eurotrope is used for the conversion of RDX, which is the strongly explosive only by mixing of concentrate HNO3. So this is one type of reaction. Now aldehydes, formaldehyde, after this one only. Next reaction is B. Aldehydes and other than the formaldehyde, aldehydes and ammonia reaction. Aldehydes reacts with ammonia only. First forms only or CHOH and NH2 like this one. HNH2, H is added to oxygen and NH2 added to this one. This is the nucleophilic addition reaction only. But here this reaction will not stop only. From this one only, OH and NH, here OH only, here H only. From here to here, one water molecule is eliminated. Therefore, we obtain aldoxymes and aldoxymes are obtained. In case of aldehydes, reacts with ammonia to form addition product. This addition product convert into the aldoxymes. This is about the aldehydes. And next one with ketones. Next to C only, ketone and NH3 reaction. I am taking ketone as a CH3 and this one. Acetone is the example for the ketone. When it is reacted with NH3 only to form with this one CH3 and CH3. This is one CH3, this second CH3 and carbonyl group OH NH2. This one it is HNH2. H is added to the oxygen, NH2 added to the carbon. This bond shifted to this side. Now O becomes as a OH and carbon bonded with the NH2 group. Now it reacts with second molecule of, so this is the second molecule only, second molecule of acetone, second molecule only. Now here I am showing it separately only. This H and OH eliminated as a water molecule only to form this one CH3 and CH3, NH2, CH2 and C double bond O CH3. This is called as ammonia diacetone, ammonia diacetone. These are the different compounds and which are forming with reaction with NH3 and okay na? That means formaldehyde is forming eurotrope with NH3 and aldehydes are forming aldoximes with NH3 and ketones are forming ammonia diketones with NH3 and now one more reaction between benzaldehyde and ammonia. Reaction D between benzaldehyde and ammonia. Benzaldehyde and ammonia. Here 3 molecules of benzaldehyde and C6H5 CHO is reacting with NH3 to form and so this is reaction C6H5 CH double bond O C6H5 CH double bond O and here N H C6H5 C double bond CH double bond. By using this one only, here this will be break only. From here to here bond will be broken only. At that stage only, here what happens, in this case this hydrogen also eliminated. That's why here forms only nitrogen to carbon double bond, okay, and C6H5. Another bond, this one, single bond, CH C6H5 CH double single bond C6H5 CH double bond N and N single bond CH C6H5. This will be formed. Okay, this is hydrobenjamide. It is called as hydrobenjamide. And this is addition with ammonia. Okay? After this one, next to reaction, next addition reaction, addition with water. With water. Addition with water. So this is important one. Addition with water is an important reaction. In this case only, carbonyl compound reacts with water to form this one, gem diol or hydrate అంటారు. Hydrates అంటారు. Forms carbonyl hydrate or hydrates అంటారు. Okay, here in this reaction H2O acts as a nucleophile. Acts as a nucleophile. Mechanism: carbonyl group. This reaction takes place in acid or base catalyzed reaction. This reaction is acid or base catalyzed reaction. Okay, what is this acid catalyzed anti? In the presence of acid, what happens? This C double bond O group, in the presence of acid anti, this bond shifted to this side anti. At that stage anti, OH and carbocation is formed. Now H2O added to this position, and OH here OHH, it is donated plus. Initially we added one H plus ion. Now here H plus ion is removed. Then we obtain COH and OH. So this is called as gem dipolar. Gem means only the two OH groups are bonded at same carbon. Gem, the same, two OH, one OH is whole, two times, that's why it's divalent, gem divalent. Yeah, in second one, in the presence of base, I am taking as a OH minus base. In this case, first base is attacked. This one is attacked to this position and it is eliminated. And that's why O minus here OH. After this one, hydrolysis of means only water. This bond shifted to this side. The H plus ion added to this one. The OH minus which is previously added, that is eliminated to obtain gem dipolar. So this is the mechanism. That's why carbonyl compound reacts with water to form gem dipole, or it named as a dihydrates, the only hydrates, gem dipole or hydrates. Carbonyl compound reacts with water to form gem dipole or hydrates. It is also called as hydration of carbonyl compounds. This reaction is a reversible reaction, and gem dipole is a unstable. Again, by the elimination of one water molecule only, this is shifted to this side, this will be eliminated. H plus OH minus H2 only. But again carbonyl compounds are formed. The reversible reaction is favorable for the maximum number of carbonyl compounds. For the maximum number of carbonyl compounds, only reversible reaction is favorable, because the gem dipoles are unstable. Backward reaction is proceeds. Okay, the stability of gem dipole and so this is very important one. The stability of gem dipole depends on neighboring group. The stability here, this one only. So this is the gem dipole. In this one only, the bond is eliminating. So this bond is eliminating, and this is the weak bond. This is the weak bond. To strengthen this one, we want to increase the positive charge at carbon. If the positive charge increases, there is attraction between carbon and oxygen, or this bond is strongly attracted. If we have positive charge, this bond will not easily removed, and this bond will be strengthened. That's why in the presence of in the presence of electron withdrawing groups. Electron withdrawing groups like chlorine or NO2 group, the stability of gem dipole increases. The stability of gem dipole depends upon this neighboring group. If here electron withdrawing group is present, the reactivity or stability of the gem dipole increases. Based on this one, I am giving some examples. HCHO, this is called as formaldehyde. Formaldehyde plus water will give stable gem dipole. This is the stable gem dipole. This is nearly 100% will be formed. 100% will be formed. And this means formaldehyde gem dipole is this gem dipole most stable. Why? Because there is no alkyl groups. Here one more point is CH3 or any alkyl group is electron releasing group. Electron releasing means here positive charge will be decreases. Alkyl groups present, that is unstable. I am taking this is one alkyl group H double bond and plus water molecule. So this is the acetaldehyde gem dipole. This is only 5% will form it. 95% only in the form of this one. This is also unstable. This is also unstable. You take so this is another example, CH3 and CH3 plus water. I am expecting this reaction, but here only 0% of gem dipole is obtained. And that means the total gem dipole which is formed is back reaction. It takes in the back reaction. That's why acetone gem dipole is unstable, acetaldehyde gem dipole is unstable, but the gem dipole which formed from the formaldehyde is somewhat the stable one, because of there is no alkyl groups and there is no electron releasing groups. Here one electron releasing group, here two electron releasing groups. Electron releases means this electron releases, here positive charge decreases. Here also positive charge decreases. That's why the stability of these two gem dipoles is less. That's why backward reaction proceeds. The total gem dipole again converts into the carbonyl group. One more important one, that is, so this is called as chloral. So this one is CH double bond O C L Cl Cl. This is trichloro acetaldehyde. Trichloroacetaldehyde reacts with water to form this one Cl 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 and CH OH OH. So this is called as here H and CCl3 and OH and OH. This is the structure. Here three chlorines are present. These three chlorines are electron withdrawing groups. That's why here also electrons are withdrawn towards the chlorine. That's why here positive charge increases. The stability of this bond will be increases. That's why this is the most stable one. Most stable one. That's why here the reaction is the name of this compound chloral hydrate antaru. Chloral hydrate, so this is also 100% will form. 100% here forms here 100%. Here question and the important one is why chloral hydrate is most stable gem diol. Explain antaru. In chloral hydrate there are the 3 chlorine atoms. These 3 chlorine atoms are electron withdrawing groups. This due to the electron withdrawing nature, the bond between the carbon and OH is the stable bond. Carbon and OH, the stable bond. That's why this will not decomposes at general conditions, at normal conditions. That's why it is the most stable one, and it is the most stable one. So this is the addition with water, and that's why the very important and carbonyl compound reacts with water in acid medium or in base medium to form gem diols. And gem diol is unstable one. It again decomposes and lose one water molecule to form back the carbonyl compounds. And that's why the reaction with water is the reversible reaction. Is the reversible reaction. Okay, and maximum number of carbonyl compounds are does not involved in this reaction. Only few compounds reacts with water to form stable gem diols or hydrates. This depends upon the neighboring groups, nature of the neighboring groups. And if electron withdrawing group is present in the gem diol, it is the stable one. If electron releasing group present in the gem diol, it is unstable. That's why acetaldehyde and acetone does not form stable gem diol or hydrate. This is due to the presence of electron releasing group, that is methyl group. In acetaldehyde 1 methyl group, in acetone 2 methyl groups are present. That's why these two are the unstable. But formaldehyde and trichloroacetaldehyde, it is also known as chloralan. Trichloroacetaldehyde, another name is chloralan. Chloral. Okay. Trichloroacetaldehyde or chloral will form stable hydrates, and this is because of the hydrate of formaldehyde has no electron releasing groups, and only 2 hydrogens are present. That's why the stable hydrate. And also in chloral hydrate 3 chlorine atoms are present. These 3 chlorine atoms acts as a electron withdrawing groups. That's why the stability will be increases. Chloral hydrate is the most stable one. And okay, so this is also used in the preparation of chloroform, and chloral hydrate is the band component. Okay, so this is addition with water. Addition with water. We completed and the nucleophilic addition reactions. And carbonyl compounds undergoes 2 types of reactions. One is the nucleophilic additions. Second one, reactions of alpha hydrogens. Reactions of alpha hydrogens. Reactions of alpha hydrogens are another name base catalyzed reactions. Reactions of carbonyl compounds. Base catalyzed reactions of carbonyl compounds are named reactions. Named reactions. This is important, very important topic. And in this one, This is the functional group andi. This is the functional group. The next carbon is known as alpha carbon. The hydrogens present on the, so this is the functional group andi. Functional group. This carbon is called as alpha carbon. Alpha carbon. The hydrogens present on the alpha carbon are known as alpha hydrogens. Here in carbonyl group andi, this alpha hydrogens exhibits acidity. Acidity. Why the acidity is exhibited andi? This is the hydrogen andi. This hydrogen, this one, if shifted in the presence of base, that's why base catalyzed reactions we are seeing as a base catalyzed reaction. In the presence of base, this H plus ion OH minus eliminate as a water molecule to form only this minus and C double bond O, this one. So this is called as carbene ion. This is called as carbene ion. This carbene ion is stabilized by resonance. So this one shifted to this side, this one shifted to this side. At that stage only, here double bond and C O minus. O minus this one. So this is the resonance structure 1 and this is the resonance structure 2. Due to this reason, this carbene ion is stabilized by resonance. That's why this H plus ion acts as a acidic H plus ion. The hydrogen, the alpha hydrogen acts as a acidic hydrogen. Okay, that's why reactions of alpha hydrogens, in this one carbene ion is formed. Okay, I am taking some examples only. Example 1, this is the formaldehyde, HC double bond O, H. Here no alpha hydrogens are. No alpha hydrogens are. Alpha hydrogens are absent. Alpha hydrogens are absent. That's why this will not involved in the base catalyzed reaction, but due to the high reactivity only, this can be involved in the some of the reactions and some of the Nemour reactions. Second example, I am taking acetaldehyde. This is called as acetaldehyde. In this acetaldehyde, H, C double bond O, H. Now this is the functional group. This is the functional group. Here this is the alpha carbon and here 1, 2, 3. Totally 3 alpha hydrogens are present. 3 alpha hydrogens are present in the acetaldehyde. One more example only. I am taking third example only. So this one CH3, C double bond O, CH3. This is called as acetone. Acetone. So this is the functional group. So this one is alpha carbon. Here also alpha carbon. Alpha carbon means which bonded to the functional group. Now this is the functional group. From right side 1 carbon, left side is also 1 carbon. That's why in this one 2 alpha carbons are present. Totally 6 alpha hydrogens are present. 6 alpha, here this 3, here this 3. Total 6 alpha hydrogens are present in the acetone. And fourth example only, C6H5CH1. This is the functional group only. It is called as benzoaldehyde only. Some of the students only, they may mistaken only. Here 5 alpha hydrogens are present. They can expect that, but that is wrong. Here the structure of benzaldehyde is this one. This is the structure of benzaldehyde. Here this is the functional group. This is the functional group. Here this is the alpha carbon. There is no, this is the alpha carbon and there is no hydrogens at alpha carbon. At alpha carbon there is no hydrogen. That's why no alpha hydrogens. In benzaldehyde there is no alpha hydrogens. One more example, because these are useful in the writing of name reactions. We have aldol condensation, we have Kenny-Joro reaction, we have Perkin reaction, Navier-Stokes reaction. So many reactions are present, benzoin condensation. In that one, the alpha hydrogen statement is very useful. That's why I am giving some of the examples how to determine, how to detect alpha carbon and alpha hydrogens. In formaldehyde there is no alpha carbon and there is no alpha hydrogens. In acetaldehyde, here this one is the functional group. Next carbon is known as alpha carbon and 3 hydrogens are present. That's why 3 alpha hydrogens present in the acetaldehyde. In acetone, this is the functional group. Here 1 carbon, here 1 carbon. Totally 2 alpha carbons are present. That's why totally 6 hydrogens, alpha hydrogens are present in the acetone. Next, fourth, we are taking benzaldehyde. Some maximum number of students are mistaken in this example because here 5 hydrogens are appearing, but according to the structure and the total 5 hydrogens are other than the alpha carbon. That's why this only alpha, beta or gamma carbons. That's why there is no alpha hydrogen. That's why alpha hydrogen is absent in this one. One more example, and so this is acetophenone. Acetophenone, this is the functional group. Here no alpha hydrogens, but here this is the alpha carbon and that's why 3 alpha hydrogens are present. One more, sixth example, and so this is benzophenone. Here also no alpha hydrogens. No alpha hydrogens in benzophenone, no alpha hydrogens in the formaldehyde, no alpha hydrogens in the benzaldehyde. Alpha hydrogens are present in the acetaldehyde, alpha hydrogens present in the acetone, alpha hydrogens are present in the acetophenone. This is the today class, and in next video the important topic and aldol condensation, Kenny-Joro reaction, Perkin condensation, benzoin condensation. The name reactions will be in next video. Thank you very much.